Now, because triggers see every change that's happening to that table, they're always enforced. They're perfect for auditing data changes, which is useful for SOX compliance and just making sure that any data changes are audited. I'll tell you a story. I was working as a consultant on a job, and we were building the application. And this particular application had to have data inserted by a third party. So we delivered a beta of the database to this third party so they could start populating the database. And we continued to develop the code. We thought everything was fine. Then the third party comes to the client and says, oh, we're really behind with all of our work because the application they gave us was so buggy we haven't been able to get anything put in. Well, we had told them we had an audit trail, but I guess they didn't pay attention because we were able to go to the database and say, well, look, during the 2 weeks you said it couldn't work, you inserted 70,000 rows, and we can tell you the exact time you changed every value. So auditing your data can really save your bacon. It's a good thing to do. There are lots of different schemes for auditing your data, from the very simple scheme that just has a duplicate table that keeps a track of the last value for every column and every row. This is a pretty robust scheme I'm going to show you. It uses an audit table, and in the audit table, you'll see the date of the change, the user who made the change, the application they were using, what table they changed, the operation was whether it was an insert, update, delete, then the primary key, if they are changing a secondary row, like the order detail row of an order, here's the ability to say the row description, meaning it was order ID 12, and then secondary row order ID value, and the secondary row order detail ID value, and then here's the meat of it, which column they changed, old value and new value. So it's a pretty beefy audit table. I'll go ahead and create this in the OBX Kites database. And the trigger. This is a pretty massive trigger, so I'll walk through it as you'll see as it starts repeating the similar code where we won't walk through every line. So this trigger is going to be on the product table for all inserts and updates. Here we're declaring a variable just to keep track of what operation it is. First off, if there's anything in the deleted table, we know it's an update, otherwise it's going to be an insert. So that's how we can tell which operation is taking place. Then for each column, we go through and figure out what's changed. Looking first at product category ID, we will select the current time. This tells us the current user, which application is connected to SQL Server. We know where they're in the product table. Here's that operation variable we looked at. Then, from the inserted table, here's the product ID or the row we're looking at. The product code will give us the row description. There is no secondary row for this particular update. The column that we're touching is product category ID, and that's what we're checking. Then OPC is the product category, and we're going to look up the names to see what they changed it from. And then here's the new product category. Because it's a foreign key, we're going to go do a join to find the actual product category names. Rather than just saying they changed it from product category 2 to 7, we can see they changed this product from kite to toy, for example. In the from clause, we're looking at the inserted. A left outer join to delete it just to make sure we get every inserted, whether there's a deleted row there or not. So this will handle inserted and updated situations. And then we actually compare the product category ID, the old version to the new version, and only if it's different, go ahead and write this row. So quite a bit's happening here for each column. And you'll see this gets replicated in some form or another for every column in this table. Then product description, active date, discontinue date, and so on. So let me create this. There. So let me create the trigger, and then we'll test it. So, with this cool audit trail trigger in place, let's run a stored procedure to insert a kite. And this is the same stored procedure we use in the OBX populate script. And this stored procedure will take a few parameters, make sure everything is okay, then do the insert for us. This is a normal real-world situation. And execute. Should be product code 200, called the Monster Kite, and the description is, man, what a big kite. And if we look at the audit table and just see what's there, you can see that we inserted some data. So into the product table, row description 200, meaning the product code, which is the meaningful row description for the product table. Here's every column and a new value because we just did insert. If you want to see the whole data, I'll just do a select star from audit. Here's the audit date, the system user. That's who I am logged in to this machine. Right now we're using Management Studio and the query editor. Here's the actual primary key that we're affecting, that we inserted. And there are no old values. So that was an insert. Let's prove it out by running an update as well. All we're going to do is change the product description to biggie sized. And remember, the old version is, man, what a big kite. Okay, and if we select old values and new values from audit for the product table, you'll see there's all the data. Let me go ahead and run the whole query here just to limit this down to product description. We can see that in that column, to see a trail of everything that's been in that column, it initially was null, and it was inserted to man, what a big kite. Then at 51 seconds and 4:40, the data man, what a big kite was changed to biggie size. So with just a little bit of work, you could build an application where a certain tab or a right click could show every value that has ever been in that column or for that row. And if we have all the data, we could even roll it back automatically as well. And that's what this next procedure will do. So here's a procedure called audit rollback. We pass to it just the audit ID, which is one row in the audit table of the change we're going to undo. And you'll see we're actually putting together an update command which will go back and set the value in the table to the new value of that audit line. And then we'll test it by finding the audit ID where it was man, what a big kite. And then executing, passing that audit ID in. And checking the data. Sure enough, we've rolled back using the audit trail to man, what a big kite. Some other cool things you could do, we don't have enough data in the audit trail right now, but you could go ahead and say, show me every change that Mary did. Show me every change that happened database-wide during this 1 hour. As far as measuring your transactions, the audit trail could even give you good information about how many transactions per second on a logical level are taking place. So, audit trails, complex RI, keeping up with the modified date, doing some good data validation. Triggers are good for all of these things. Just remember the trigger takes place inside the transaction, and you don't want to kill performance with triggers that are overly complex.